Charging by induction using a negatively charged object to charge a neutral object. So here is our negatively charged object with pluses of 1, 2, 3, 4, 5, 6, 7, 8 pluses and 12 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is negatively charged. Since this is the charging object, nothing will happen to it. So I could just say, there's my negative object, just for ease of understanding it. Now here is my neutral object. My neutral object has the 8 pluses, 1, 2, 3, 4, 5, 6, 7, 8, and the 8 negatives, so it's neutral. Now, what you do is you bring them close together, and now the negatives and the negatives repel each other. We don't care what happens here, but we do know that these negatives that are repelled will all go to the other end, making this end over here locally negative and this locally positive. Then we keep this close. Oh, now they're going to go to the bottom. Now we ground the neutral object. And when we ground the neutral object, there is an unlimited source of electrons in the earth that this is touching. So all the electrons are trying to get away from the negative. Now it has a path to escape now that it's grounded. So a bunch of the electrons will be able to finally escape. Now eventually, depending on how negative this is, the forces will balance out. Now, the next thing you do, and it's important the order, you disconnect the ground so these guys can't come back up. So you disconnect, so these guys are still there. And there's only 4, they can't gain or lose them. You remove the charged object, and what you got left with is a charged positive object. This used to be neutral. It lost electrons, and now it is left with the same 8, because that can't change, protons, but only 4 electrons, so this is now positive. When you charge by induction, you get the opposite charge. I used a negative to bring it close, attach it to ground where the extra electrons traveled to ground and escaped, got rid of the ground, got rid of the charge, and now I have a positive.